we can sketch the graph the rational function by using transformation. So for example, given f of x equal to negative 2 over x minus 2, as we can see that this graph here is moved to the right 2 units. We have a vertical stretch of 2, and it's also reflect across the x-axis. Compared to the graph of f of x equal 1 over x. Okay, so then now the vertical asymptote become 2, x equal 2. And it's stretched by a factor the 2. And also reflect across the x-axis. Okay, so this means when x equal to 3, y equal to negative a half, and the shape of the graph is going to be like this, right? Because it is the graph of a rational function. Again, on the side, it's going to look like this. And we try our best to make it accurate and smooth curve as possible. So this is the graph of f of x equal negative 2 over x minus 2. Now in the next case, we get f of x equal 2x minus 9 divided by x minus 4. The best way to figure out the transformation is start with the long division. So x minus 4 into 2x minus 9. So this is 2. So 2x minus 8, subtract 0, and here is minus 1. So then f of x is now become 2 minus 1 over x minus 4. So here we can see that it moved to the right 4 units. Reflects across the x-axis. And move up 2. So then now we have the vertical asymptote at x equal 4. The horizontal asymptote is at y equal 2. And the graph looks like this. So this is the graph of f of x equal to 2x minus 9 divided by x minus 4. Okay, so the domain and range. So talk about the domain. In our first graph, the domain here is from negative infinity to 2 union with 2 to positive infinity. The range is going from negative infinity to 0 union with 0 to infinity. In our second graph, the domain is negative infinity to 4 union with 4 to positive infinity. Note that this is where the vertical asymptote. The range is from negative infinity to 2 union with 2 to positive infinity, and note that this is the horizontal asymptote. The asymptote of rational function. The vertical asymptote. To find the vertical asymptote, we determine the zero of denominator and then see whether y approaches infinity or y approaches negative infinity on each side of vertical asymptote by using test value. Okay. The horizontal asymptote. If the degree of the numerator greater than the degree of the denominator, and we have no horizontal asymptote. If it's the other way around, then we have the asymptote at 0. If the degree is the same, then the horizontal asymptote is the coefficient. This is the quotient of the leading coefficient of p of x and q of x. Now, for the case that m is greater than n, f have no horizontal asymptote. However, it has length asymptote. Next problem, we want to find the horizontal asymptote and vertical asymptote if there's any. To find the vertical asymptote, we set the denominator equal to 0. So note that we want to factor this, right? So let's factor this. 2 times negative 5 is negative 10, so this is not factorable. To factor this, I can either complete the square, or I can solve for x here by using quadratic equation. So x equals negative b plus or minus square root of b squared minus 4ac divided by 2a so this equal to negative 1 plus or minus square root of 41 divided by 4. Okay. So here we have two vertical asymptotes. So these are the two vertical asymptotes. For the horizontal asymptote, note that the degree of the numerator is 2, and the degree of the denominator also 2. So this means the horizontal asymptote is determined by the coefficient of the numerator divided by the leading coefficient of the denominator. So that is your horizontal asymptote. The next case, the vertical asymptote. Again, we will set the denominator equal to 0. And this should say 4x squared. 4x squared minus 7x plus 1 equal to 0. Again, to factor this, I'll use the quadratic equation. Again, here we have two vertical asymptotes. The horizontal asymptote. The degree of the numerator is less than the degree of the denominator. So then in this case, the horizontal asymptote y equal to 0. Find x and y intercept of a rational function. Well, to find y-intercept, it seems simple. Y-intercept will let x equal to 0. So then y equal to 0 squared minus 0 minus 2 divided by 0 minus 6. That gives us a third. The x-intercept is different. We let y equal to 0. If y equal to 0, then x squared minus x minus 2 divided by x minus 6 have to equal to 0. This implies that x squared minus x minus 2 equal to 0. We can factor this to get x minus 2 times x plus 1 equal to 0. So then x equal to and x equal to negative 1. So these are the x and y intercept of the rational function.